So, hi guys. Today we're looking at the Mathematics Ordinary Level Paper 2. This was the paper that was written in 2021. So it's a 3-hour paper, and let's see how it goes. Right, so whenever you're writing an exam, always make sure that you read the instructions, make sure that you follow them, and do everything that is required of you. Okay, so question 1, state if the answer to each of the following numbers and expressions is rational or irrational. So you need to remember, what is a rational number? A number is rational if you can write it as a fraction where your numerator is an integer and your denominator is an integer. Okay, now 0.7 and then there's a dot on top of the 7. You need to remember that this is equal to 0.777, and the 7s go on forever. All right, now one thing we know about rational numbers or irrational numbers as well is that a number is rational if it is a decimal and the decimals are recurring. So recurring means they repeat themselves. Like the one we have over here, the 7s are repeating themselves, so that means we have a recurring decimal. So this is recurring, and therefore 0.777 and so on is rational. Okay, B, we have the square root of 5 minus the square root of 5. This one, we don't even need to do any complex calculations. This is just equal to 0 because we know whenever we subtract anything from itself, the answer is 0. And 0, you can write it as a fraction. For example, you can write it as 0 over 1. This is an integer that is also an integer. So square root of 5 minus square root of 5 is rational. Then our next one, square root of 5 plus square root of 5. This one, if I were to do it without a calculator, would give me 2 square root of 5. And if you wanted to see it on the calculator, we have the square root of 5 plus, plus the square root of 5. This is equal to 2 square root of 5. And if I were to write it in decimal form, you can see that my decimals are non-recurring. And whenever we have unending or an infinite number of decimals that are non-recurring, they do not repeat, what we have is an irrational number. So this is irrational. Then D, we have the square root of 5 divided by the square root of 5. This is just equal to 1. I don't need a calculator in order to figure that out. And 1 is a rational number because I can write 1 as 1 over 1. So this is 1. And then square root of 5 times the square root of 5. This is, if I were to do it without a calculator, this is the square root of 5 times 5. Both of the 5's come under 1 square root and the multiplication as well. So this would be the square root of 25, and this is just equal to 5. 5, as you know, you can write it as 5 over 1 or even 10 over 2, which is still a fraction. So this is rational. Then number 2, we're given the formula V is equal to U plus AT, and we're told that this is used in science. I think from physical science or physics, you'll remember that this is the formula for the final velocity when you're given the initial velocity and acceleration and time. Now A says work out V when U is 8, A is minus 10, and T is 7. So it's just a matter of substituting into the formula. So we have V. I'm just going to rewrite the formula as AT. Then substitute. What is my U? It's 8. And then I have A. This is negative 10. You must put it in brackets. And then times T, which is 7. You can also put it in brackets. So exactly the way I have it here is how you would type it in on your calculator. So you have 8 plus, open brackets, negative 10, close brackets, and then you can either use the multiplication symbol or you can have brackets over there for the 7. Either one is fine, and that is equal to negative 62. So our final velocity is negative 62. So write the answer over there is negative 62. B says make A the subject of the formula. So V is equal to U plus AT. So what you want is to first have all the terms without A on one side and the terms that have an A on the other side. So you can see this U does not have an A, so it can go to the other side. On the right hand side it is plus U, so the opposite of plus U is minus U. So I would subtract U on both sides. These two will cancel. So I have V minus U is equal to AT. And I can always rewrite this as AT is equal to V minus U. So if this is equal to that, obviously then this is equal to that. And then we want A to be alone. That's what it means to make A the subject of the formula. You want A to be isolated on one side and all the other terms on the other side. So there must be only one A appearing. So sorry, not dividing by A. So we're going to divide by T because we want A to be alone. So divide by T. These two T's will cancel. So I have A is equal to V minus U over T. So write the answer over there, over T. Question 3. The dimensions of the cuboid shown below are given correct to 1 decimal place, and this is the sketch that we are given. We're told that it is not to scale. Now we want to find the minimum volume of the cuboid. Now remember, these are approximations, or they're given correct to 1 decimal place. And that means they may not have been exactly 6.2. It could have been maybe 6.19, 6.199, and so on. And the same thing with this one. This could have been 6.27, for example. Okay, now what we want to do is find the minimum volume. Now, when you round something off to 6.2, you need to figure out what is the range that that number had to be in for me to round it off to 6.2. So you can say this 6.2 had to be between 6.15. So we know that if we want to round it up to 1 decimal place, you look at the second decimal, and then if it's 5 or more, then this number you add 1 to it. Or it could have been 6.24. That is the range, because if I have a 4 here, 4 is less than 5, then I would just drop the 4 and then leave it as that. Now what we want to find out is the minimum volume. So the minimum volume, we will get that if we have the minimum dimensions. So this value here, we need to find out what is its minimum. this value here, we need to work out what is its minimum, and the same thing with this one over here, we need to find out what is the minimum. And using all three minimums, we can multiply them to give us the minimum volume. Now this 6.1, the minimum value is obviously 6.15. Then we do the same thing with this one. If I have a number 9.3, the lowest it can be to 2 decimal places, so that I would have to round it off to 9.3. It will be 9.25, because if it's 9.24, then I'll just drop the 4, and then this 2 would remain 2, but we want to be able to round it up to 9.3. And then the largest that it can be is 9.34. Again, you'd look at the 4 and say the 4 is less than 5, so this 3, the 4 will be dropped, and then the 3 remains as it is. Also do the same thing for the 3.1. So 3.1, we need to find the minimum and the maximum. So this is 3.05, and the maximum that it can be is 3.14. Okay, then again, because we want the minimum volume, what you do is you take all three minimum dimensions and you will multiply them to get our minimum volume. So our minimum volume, this is going to be the minimum length times the minimum width times the minimum height. Okay, so that you just type in on your calculator the way I have it. We have 6.15 times 9.25 times 3.05, and we have our answer there. So I'm going to write down the full calculator display. At first, this is 173. Okay, that's 173.506875. Okay, now remember I said you must always follow the instructions that are given in the paper, and it says that if the accuracy is not stated, like it says leave your answer to this many decimal places or this many significant figures, what you need to do is leave it to 3 significant figures. So when I rewrite this to 3 significant figures, I will have 1, 7. Those are 2 significant figures. I look at the third significant figure, it's a 3. Then the next significant figure that comes after that is a 5. So I would round this one up. So this would be 174, and my units are in centimeters cubed. So then you come down and write your answer as 174 centimeters cubed, and this is of course to 3 significant figures, because those are the instructions that are given on the front page. Okay, number 4, in the village of Sibinda, not all houses are connected to electricity, tap water, or gas. The following, this is represented by the following sets. So we have our E here, which represents our universal set. The universal set is all the houses that are in Sibinda. Then we have E, that represents the houses that have electricity. W is the houses that have tap water, and G are the houses that have gas. Okay, now A says express in set notation the relationship between E and W. Now you can see that this set E is or this circle, I'll refer to them as circles, you can see that this circle E is completely inside the circle W. And when we have such a scenario that one set is completely contained in another set, we call that a subset. So we say a subset. So that means one set is contained in another. So we say that one set is contained in another. So we would then say that E is a subset of W. Okay, so it's a set within another set, and the symbol we use for subset is this one, or sometimes you will see it with a line like that. So here we would write that E is a subset of W. When the line under the C is under the symbol is not given, that means it is completely contained. Now this line that is underneath gives room for these two sets to be equal. Okay, so a subset is a set that is contained in another, but it is possible for one set to be contained in another set and the second set also contained in the first set. So they are subsets of each other, and this line that we have under the symbol gives room for the two sets to be equal. Okay, then it's smaller. Okay, so house P, so we have a house here, has been indicated in the Venn diagram. Give 3 pieces of information about house P. Okay, so here we have to look at where the letter P is in relation to these circles, and then then we can say whether it has gas, water, and electricity. Now, because P is in the universal set, something that is obvious but can state as well is that P is a house in Sabinda. So this is obvious, but there's no harm in stating something that is obvious. Then you can see that P is contained in the circle W. That means it is one of the houses that have tap water. So P has tap water. And then you can see that P is contained in the circle G. So that means a P is one of the houses that has gas. And then you can see that it is not contained in the circle E. That means P does not have electricity. P does not have electricity. Okay. Then C on the diagram, shade the subset G intersect E. Okay, this symbol here represents an intersection, and the way to remember this intersection unions is try and think of the intersection of a road. So you have 2 roads that go like that. This is the intersection of the 2 roads. You can see this part that I've shaded here is on this road, and it is also on this road. So an intersection is on both roads. So what you want to shade when you're asked to shade G intersect E, you want to shade an area that is in the circle G as well as in the circle E. Okay, so this is the circle G and this is the circle E. Now the only area that is in both circles is this area here. So you can see that area over there, that is inside the circle G, and it is also inside the circle. So with your pencil you would be able to shade it much better than I have done here. Okay, and it'll be very clear what you have shaded. So an intersection, it must be in both. It is not enough that it is in just one of them, it must be in both. So this region here, like I said, is inside the circle G and it is also inside the circle E. So that is what intersection means. Okay, then mark on the diagram the house Q that is connected to tap water but not gas and not electricity. So what we want is a house that is inside the circle W and not any of the other circles. So we go to our diagram, so tap water but not any of the others. So you could play around with this, try and figure this out. If I put it here, yes, it is in the circle W, but it is also in the circle E, and that's not what I want. If I put it here, it is in the circle W, but it is in the circle G, or for gas, which is not what I want. Okay, and the only place I can put it is anywhere in this region over there, because if I put it there, then you can see that it is in the circle W. That means it has tap water. It is not in the circle E. That means it does not have electricity, and it is not in the circle G. That means it does not have gas, and therefore fulfills what it is that we are asked to find. Okay, number 5, we have to simplify as far as possible the following. Okay, we have 2x cubed y squared cubed. Now here, simply using our laws of exponents, when you have a product that is raised to an exponent, you can simply distribute the exponent. So this you can rewrite as 2 to the power of 3 multiplied by x cubed to the power of 3. So it's this x cubed here to the power of this 3 there. And then you multiply this by y squared to the power of 3. So you take this y squared here and then raise it to the power 3. So you can see each of the terms inside the bracket, you raise them to the power there, and this is unique to multiplication and division. So this does not apply when you have an addition. So something, a common mistake that I see quite a lot, I just need to take note of that. You need to note that if I have something like 2 plus x cubed to the power of 3, this is definitely not equal to 2 to the power of 3 plus x cubed to the power of 3. So I cannot tell you how many times I see a mistake like that. So don't make this mistake. The distribution of the exponent over here, this only applies when you have a multiplication. So if you're adding or subtracting over here, you cannot do this. That is wrong. Okay, then these you can work out. 2 to the power of 3 is 8, and then x cubed, remember our laws of exponents. If I have a base with one exponent and then raised to another exponent, what I do is I simply multiply the two exponents. So this will be x to the power of 3 times 3, which is 9. And then here, same thing, I have y to the power of 2 to the power of 3. You simply multiply the exponents, you get y to the power of 6. So this, when I write it without the multiplication symbols, I'll have 8x to the power of 9, y to the power of 6. Then b, we have x squared minus x minus 12 over x squared plus 6x plus 9. Now, at first glance, it might be tempting to say, okay, can I not just cancel x squared there and then this x there, something like that? No, you definitely cannot do that. That would not be correct. So we don't cancel terms when we have additions like that. So what you need to do is you need to factorize your numerator and factorize the denominator and then see if there are any terms that can cancel. So if I look at the numerator, it's a quadratic trinomial and we know how to factorize that. You look for two numbers that when you multiply them, the answer is -12, and when we add them, the answer is -1. So the two numbers are -4 and +3. So this term here in the middle, I will split it up as -4x plus 3x. So we have x squared minus 4x plus 3x minus 12, and you can see -4x plus 3x is equal to -x. So the only thing I have done with this expression in the numerator is to expand it, make it longer. Otherwise it is still exactly equal to the one I have there. Then in the denominator, I do the same thing. I look for two numbers. When I multiply them, the answer is 9, and when I add them, the answer is 6. Those two numbers are 3 and 3, both positive. So I would then again expand this, and I'll have x squared plus 3x plus 3x and then plus 9. And then factorizing, I would look at the first two terms and also the last two terms. What do they have in common? And factorize, I will do the same thing in the numerator as well as the denominator. Okay, now in the numerator, my first rectangle, I have x squared and minus 4x. What is a common factor? X. So I would take the x out, and I'll say x squared divided by x is x. -4x divided by x is -4. And then here, the second rectangle in the numerator, I have 3x minus 12. What is a common factor between them? 3 is a common factor, so I would take out 3. And then I say 3x divided by 3 is x. And then minus 12 divided by 3 is minus 4. And then move on to my denominator. So my first rectangle in the denominator, x is a common factor. When you take that out, you have x plus 3. And the second bracket, 3 is a common factor. And then you have x plus 3. And then now you can see that I have in the numerator x minus 4, that's a common factor, so you can factorize it out again. Same thing with the denominator, x plus 3 is a common factor. So you would then factorize fully, and you would have x plus 3, so this x here and this 3 there. Then you take one of these two brackets which are identical, you have x minus 4, and then in the denominator you have x plus 3, and then either of these brackets, which again should be identical before you rewrite it like that. Then we said our reason for factorizing is we wanted to be able to cancel some terms, and the way you cancel is you cancel out entire brackets that are the same in the numerator and in the denominator. So I can see in the numerator I have x plus 3. In the denominator, I have a bracket x plus 3. So I cancel the entire bracket like that. So what I do not want to see, or what you should not do, is say x cancels with x, 3 cancels with 3, even though in the end the entire brackets are cancelled. The reason I wouldn't advise you to do that is because it sets up your mindset for canceling out incorrectly, like I said in the beginning. So what you should do is cancel the entire bracket like that, and then what you're left with is x minus 4 over x plus 3. Okay, C. we have y over y minus 1 squared minus y over y minus 1. So here I have two fractions that I am subtracting. Remember that whenever we want to subtract fractions, the denominators must be the same. If the denominators are not the same, then you cannot subtract the fractions. So what you always want to do is make the denominators the LCM. Now, of course, when you're answering this question paper during the exam, you don't need to state that I'm going to make the denominators the same. Just go ahead and do it. The reason I'm writing all this is because I'm making an instructional video. So these are notes that you can take down as you are watching and revising. Okay, so you need to make the denominators the LCM, which is the lowest common multiple. So if you look at these two, I have y minus 1 and y minus 1 squared rather, and y minus 1. The lowest common multiple of these two is y minus 1 squared. Okay, it may be tempting to just multiply these two together, and in the end you would still get the same answer, but you'll be doing a lot of work, and the more work you do, the easier it is to make a mistake. Okay, so here for example is if I had a fraction like this, I had a half minus 1 over 4, and I wanted to work this out. I can rewrite this as over 8, but it's easier for me to just change this one to a fraction that is over 4. So I'd multiply this one by 2 to make it 4. Even though when I'd work this out, I would get my answer and then I'd have to simplify it after that, my work would be more. So you always want to do the least amount of work. All right, so our LCM in this case is y minus 1 squared. And remember, squared means something is being multiplied by itself. So what I do is I have y over y minus 1 squared. This denominator is already the LCM, so I don't need to change it in any way. And then the second one, I have y over y minus 1. And then to make it y minus 1 squared, I need to multiply it by itself. So I'll multiply by, can put it in brackets, y minus 1 over y minus 1, even though the brackets are not really needed. And here this minus y should multiply this y and also like that. So when I do this, I have y over y minus 1 squared, and minus, this is negative, I can leave it like that. So I say y times y, this is y squared. And then y times minus 1, this is minus y. Okay, and then this is over y minus 1 squared. Okay, so now I'm going to rewrite it as a single fraction. The denominator is going to be, let me rather do it over here. So the denominator is going to be y minus 1 squared. So remember, it's this numerator minus this entire numerator. So I have y minus y squared and then minus negative y. So I see this mistake quite a lot whenever we have a negative here. So what you should do is take the negative and multiply it by each of the terms in the fraction. So negative 1 times y squared is negative y squared, and then negative 1 times negative y is positive y. Okay, and then from here we can rewrite this as 2y minus y squared over y minus 1 squared. Now in the numerator you can see that y is a common factor, so you can go ahead and factorize that. So we take out the y in the numerator, then we'll have 2 minus y, and then in the denominator we have y minus 1 squared. So my final answer in its simplest form is 2 minus y over y minus 1 squared. Right, question 6. Minga designed a rectangular garden P, Q, R, and S as shown in the diagram. It is given that the section PT, so this PT is equal to HQ, and both of them are equal to X meters. The area of the garden is 150 meters squared. Show that X squared plus 19x is equal to 90. So what we can do is we can redraw our, so we have our garden that looks like this. Sorry. So this is our garden. Okay. Then this is P, Q, R, and S. Now PS, from here you can see there's X meters and then there's 4 meters. So the total length here is 4 plus X. And then PQ, you can see this is 15 meters and then there's an X. So this is 15 plus X. Now, because this is a rectangle, we know that the area is equal to the length times the width, or length times breadth. So we would just multiply PQ times PS, and then that will give us 150 meters squared. So that is given to us in the question. So we have to show that x squared plus 19x is equal to 90. So we just go ahead and multiply. So our area, this is length times width. So we have PQ times PS, and our PQ, we're going to put that in brackets. It's 15 plus x. And we multiply that. Whenever we have two brackets next to each other, or two pairs of brackets next to each other multiplying, you don't need to put the multiplication symbol between them. Then we have 4 plus x. And this is of course equal to 150 because that's the area. So multiplying out the brackets, we have 15 times 4, this is 60. Then 15 times x, this is 15x. 4 times x, or x times 4, is 4x. And then 4 times, sorry, that's not right. And then x times x, this is x squared. And this is, of course, equal to 150. All right, so on the left-hand side, I have 60. 15x plus 4x, this is 19x, and then x squared, this is equal to 150. So you can subtract 60 on both sides. You have 19x plus x squared is equal to 150 minus 60, that's 90. And then just rewriting it the way it is given, 19x plus x squared is the same as x squared plus 19x. This is equal to 90. So we have shown it as required. Then find the value of x, giving the answer correct to 3 significant figures. So we have this equation here that x squared plus 19x is equal to 90. This is a quadratic equation, so you want to rewrite it with everything on one side and 0 on the other side. So when this 90 goes to the other side, it becomes negative, or you can say subtract 90 on both sides. All right, so I'm sure you know the different methods that we use to solve a quadratic equation. You can either factorize, which is not always possible. You can complete the square, or the easiest one is to use the quadratic formula. Now this one cannot be factorized, so we have to make use of the quadratic formula. Now, very important with the quadratic formula, you must arrange your terms in descending powers of x. So this is x to the power of 2, x to the power of 1, and then x to the power of 0. There's no x there. Okay, then you identify your a, your b, and your c, and these are the coefficients of x squared, x, and the constant term. So here there's no number in front of the x squared. That means the coefficient is 1, and b is the coefficient with the sign. Don't forget the sign, it goes together with the number. So this is positive 19, and when a number is positive we don't need to put the plus. And then c, this is negative 90. Then remember the quadratic formula. We have, let me make this bigger now. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. Then you just substitute. Wherever you have b, you're going to put 19. Where you have a, you put 1. And where you have c, you put negative 90. So this is negative b, so negative 19 plus or minus the square root b squared. This is 19 squared minus 4 times a, so 4 times 1, times c, which is negative 90. And then this is divided by 2 times a, which is 1. So exactly the way I have it here, that is what you are going to put on your calculator. So let's do that. So we have a fraction, we have negative, these brackets are not necessary, but it doesn't hurt to put them. Then we don't have a plus or minus on our calculator, so you should work out the positive one first and then the negative one. So first I put a plus, then the square root of 19 squared minus 4 times 1 times negative 90, close brackets, and then in the denominator we have 2 times 1. Okay, so that is our first answer. Okay. And then we can convert it to decimal form. This is 3, so I'll write exactly what I see on the calculator. This is 3.925721582. Okay, and it says we must leave our answer correct to 3 significant figures, so this is 3.93, and this would be meters. This is to 3 significant figures. Now remember, there is another solution when we use the minus, so x is equal to this, or x is equal to, so we do this on our calculator. And what we do is we just change the plus to a minus. Okay, and that is our answer. And then converting it to decimal, we have x is equal to negative 22.925 72158. Now this one here, I can also just, for interest sake, write it to 2 decimal places, 3 significant figures rather, 3 significant figures, but this is an invalid solution, okay, or an unrealistic solution. Why is it unrealistic? Because x tells us the length of a section of the garden. Now we know that length is always positive, so since length is always positive, always positive, okay, so this would be an invalid or unrealistic. Okay, so our value for x is actually just equal to 3.93 meters. So 3.93 meters, and that is to 3 significant figures as required in the question. Number 7 is on matrices. We're given two 2x2 matrices, A and C. We have to find the product AC. Now remember, when we're multiplying matrices, it's not just a matter of multiplying corresponding elements. What we do is we multiply rows with columns and then add those products together. So I'm going to write my 2 matrices, A, and very important that the order you write the matrices in makes a big difference. So when we're multiplying numbers, for example, if I have 2 times 3, this is 6. Somebody else would say 3 times 2, the answer is still equal to 6. But with matrices, that is not the case. If I say A times C, this is not always equal to C times A. So when you're asked to work out AC, make sure your first matrix, or the one you write first, is A. So I'll write 2, 3, minus 2, 0. And then I write the matrix C, which is negative 10, 3, 8, and minus 1. So order is very important. The order matters. Okay, so keep that in mind. Now, when we multiply, we said a row times a column. So first number in the row multiplies first number in the column, and then second in the row multiplies second in the column, and then you add the 2 together. So here I'm gonna write big matrix. So I say 2 times negative 10, so I have 2 times negative 10, and then I'll add that to 3 times 8. So that was first row, first column, so it must become the first element in the first row and column. So first row, first column goes to first row, first column in your answer. Then the next one, I have first row, second column. That will become the element in the first row, second column in my answer. So I'll say 2 times 3, and then I add 3 times negative 1. And then second row, first column will go over here where we have a second row, first column. So that's negative 2 times negative 10, and then 0 times 8. And then negative 2 times 3, and then add that to 0 times negative 1. So with our first one, we can use our calculator, but of course, good to practice doing some of these sums without a calculator. So we have 2 negative 10 plus 3 So exactly the way I have it over here is how I will write it on the calculator. And this is equal to 4, so my first entry is 4. Then the same thing with the second one. I have 2 times 3 plus 0 times negative 1. This is 6. Sorry, wrong place. That's this one over here. I don't know why I worked that one out first, but don't get confused. So this one goes here, that's 6. And the order you work them out in doesn't actually matter. So next I look at this one. I have 2 times 3, so if I don't want to use the brackets, I can also do that. And then 3 times negative 1. This is 3, so 3 goes over here. And then the last entry, I have negative 2 times negative 10 plus 0 times 8. This is 20. Okay, then you would write your final answer here. So this is 4, 3, 20, and 6. Then when we want to find the inverse of a 2 by 2 matrix, there is a formula that we use. So C inverse, this is equal to 1 over the determinant of C. And then what we do is with the entries on the leading diagonal, we'll swap them. So we have D here, A here, and then the entries on the minor diagonal will multiply them by negative 1. So this is an A. Okay, so our determinant, the way we work it out is, let me write our matrix C. So C is this matrix here, negative 10, 3, 8, and negative 1. Okay, so we want to work out its inverse. So remember, the inverse of a matrix is one that when you multiply it with the first matrix, you get your identity or your unit matrix. So first thing we need is the determinant, and the determinant is simply the product of the leading diagonal. So I'll multiply these two and then multiply these two and then subtract. So my determinant, this is equal to negative 10 times negative 1 minus 3 times 8. Negative 10 times negative 1 minus 3 times 8. So you can also replace the multiplication symbols with brackets. That's also fine. You will still get the same answer, which is negative 14. Okay, then I just follow this formula. So C inverse, this is equal to 1 over my determinant, so it's 1 over negative 14, and then I transform this matrix the way I have here. So I would swap these two elements, so the -10 will go to the bottom and the -1 will go to the top. And then these two entries on the minor diagonal, I'll multiply them by -1. So I say -1 times 3 is -3, and then 8 times -1 is -8. And then this -1/14, you can multiply it inside your matrix. So it'll multiply each entry. So you'd get -1/4 times -1. This is +1/14. -1/14 times -3. This is +3/14. And then -1/8 times -1/14 times -8. That is -8/14. Of course, you should simplify that. And then -1/14 times -1/14 times -10. This is, sorry guys, where's my eraser? This should not be negative. It's positive because I have negative times negative. So this is also positive 10/14. And again, you should simplify this. So this is 1/14, 3/14. This 8/14 is 4/7. 10/14 is 5/7. So that's our final answer. Here I have 1/14, 3/14, and 4/7, then 5/7. Great. Number 8. Solve the following equations. So an example of a pretty simple equation to solve. All you do is collect the terms that have x on the left hand side and then the terms that don't have x on the right hand side. So you can subtract 7x on both sides, so you'll end up with 12x minus 7x is equal to 37 minus 8. So 12x minus 7x, this is 5x, and then 37 minus 8, this is equal to 29. Okay, and then you divide both sides by 5. We have x is equal to 29/5, and then we can write this to 3 significant figures, but it is exact, so you can just write it as 5.8 or 29/5. I actually prefer 29/5. A, B, we have fractions here. Now whenever you have a question that involves fractions, what you want to do is always get rid of the denominator. And to get rid of the denominator, you look, I have this one as 5, this one is 2, this one is 10. You should try and multiply throughout by the lowest common multiple. So this is 5, this is 2, this is 10. The lowest common multiple is 10. So I'm going to multiply each of the fractions by 10. So writing this, I have 3x plus 1/5 going to multiply that by 10. Then x minus 2 over 2 times 10, and 47 over 10 times 10. And because I've multiplied everything by 10, it doesn't have to be 10 over 10, it's just 10. Then you say 5 goes there once, it goes there 2 times, and this 2 will multiply the entire fraction, the 3x and the 1. 2 goes there once, it goes there 5 times, and then this 5 will multiply this negative 2 and the x, and then these 2 just cancel to give me 1. So we say 3x times 2, this is 6x. 1 times 2 is 2. Then x times 5 is 5x. Negative 2 times 5 is negative 10. And then 47 times 1 is 47. And collecting like terms, I have 6x plus 5x, this is 11x. And then 2 minus 10, this is minus 8. 47. Then you can add 8 on both sides. This cancels. I have 11x. 47 plus 8 is 55. And then divide by 11. We get x is equal to 5. And see, we have to solve this simultaneously. So whenever you're asked to solve a pair of simultaneous equations where only one of them is linear, what you should do is think of a substitution. And the way that works is in one of the equations, it's going to be the first one for us, you make x or y the subject of the formula. The one you choose to make the subject of the formula is up to you. So you make it the subject of the formula and then substitute into the other equation. So I'm going to just label them for ease of reference. So this is equation 1, this is equation 2. Now from equation 1, I have x minus 5y is equal to negative 13. I'm going to add 5y on both sides, or you may be used to saying the negative 5y goes to the other side. So you have x is equal to 5y minus 13. This gives me equation 3. Then what I do is I am going to substitute equation 3 in the equation that I didn't use. I've already used equation 1, so I need to use equation 2. So I substitute equation 3 into equation 2. So that means wherever I have x in equation 2, I'm going to replace the x with 5y minus 13. So this is the equation, it's x squared plus y squared is equal to 13. Now making the substitution, wherever I have x, instead of writing x, what am I going to put? 5y minus 13. So I have 5y minus 13 squared plus y squared, this is equal to 13. And very important, you need to remember what squared means. Squared means you're multiplying something by itself. So 5y minus 13 squared means 5y minus 13 times 5y minus 13. So simply squaring the 5y and then subtracting the square of 13, that would not. Okay, so you say 5y times 5y, this is 25y squared. And then 5y times negative 13, this is negative 65y. And then negative 13 times 5y, this is negative 65y. Then negative 13 times negative 13, this is positive 165. And then this y squared should be brought down. Okay, so you can see that I have a quadratic trinomial, so you want to have everything on one side, 0 on the other side. But on the left hand side I can still simplify. I have 25y squared plus y squared. This is 26y squared, and then negative 65y minus 65y. This is negative 130y, and then I have 169. I don't know why I wrote 165 here. That should be a 169 because that's negative 13 times negative 13. So I have 169 minus 13. So this 13 comes over to the left, 0. So this gives me 26y squared minus 130y, and 169 minus 13 is 156. Okay. So solving this, you can either use the quadratic formula, factorize if possible, or complete the square. So before I do any of those, I can see that all of these coefficients, 26 is a factor of theirs, so I can divide everything by 26. So divide by 26, divide by 26, divide by 26. 26 divided by 26 is 1, so I have y squared. And then 130 negative divided by 26 is 5. So I have minus 5y. And then 156 divided by 26, this is equal to 6. And here I didn't say it, but I did it in my mind. 0 divided by 26 is just 0. Then now this one is much easier because you can factorize it. You look for two numbers that when you multiply them, the answer is positive 6, and when you add them, the answer is negative 5. That is negative 3 and negative 2. So then you would write y squared, just split up my solutions, then minus 3y minus 2y plus 6. This is equal to 0. Then we have y minus 3 minus 2, y minus 3. So then this y and that 2, so it's y minus 2. And then this first bracket, which is exactly the same as that one, of y minus 3, this is equal to 0. So this means your first bracket is 0, because whenever two terms are multiplying and the answer is 0, it means either the first one is 0 or the second one is 0. So I have my y value. Now for each of these y values, I need to work out the corresponding x values. Now remember, the formula for the x value is x is equal to 5y minus 13. So I have 5 times y minus 13. So this is 5. What is my y value? It's 2 minus 13. And this you can type in on your calculator. But of course, again, you don't need a calculator. 5 times 2 minus 13. This is negative 3. So my first pair, remember these are a pair. X is 3, y is 2. And then the second one, x is equal to 5 times 3 minus 13. This is positive 2. Sorry, this should be negative. Let's just confirm that. So this was 5 times 2 minus 13. Yeah, this should be a negative 3. then the other one 5 times 3 minus 13. So just be wary of small mistakes like that, because they could end up costing you quite a bit. So here x is equal to 2. So now we write down the solutions. They go together as a pair. So my first x value, I'll take -3, so it's -3, and -3 goes together with +2. And then the second one is when x is 2, and that means y is equal to 3. So you cannot switch the order and put this 2 here and then this -3 there. That would not be correct. So you have to make sure you write this part in correctly. Right, number 9, we have a triangle XYZ is drawn, and XZ is 30 centimeters, YZ is 23 centimeters, and the angle YXZ is 46 degrees, and this angle here XYZ is y degrees. Now we have to find the value of y. So this one pretty simple to do. We are given 2 sides and an angle. What we can do is use the sine rule. Okay, and the sine rule says that sine of this angle here divided by this side here is equal to sine of this angle here divided by this side here. That's the sine rule. So sine y over 30 centimeters, this is equal to sine of 46 divided by 23. So you can then multiply the 30 on both sides. Then you would get sine y is equal to 30 times sine 46, everything over 23. And then to get y, you would take sine inverse on both sides. We're not dividing by sine. Remember that sine is not a number that you can divide. This sine and that y are not multiplying, so dividing by sine does not get rid of the sine. What you need to do is take sine inverse. So y is equal to sine inverse of 30 times sine 46 over 23, and then you type it in exactly the way I have on the calculator. So here we have second function sine inverse, we have a fraction, we have 30 times sine of 46. Very important, make sure your calculator is in degree mode, because there are other modes that we use to measure angles, or other units that we use to measure angles. So make sure it is in degree mode, because our angles are given in degrees. And this is divided by 23. Close your bracket, press enter. You get 69.76. So I'm just going to write this to 1 decimal place, because that is what we are told to do in the instructions on the front cover. So this is 69.8 degrees. Okay, the degree symbol is given over there. Okay, sometimes you may want to write the full calculator displayed. That is also fine. So this is 69.76291081. But your final answer here, you should write it to the number of significant figures or decimal places that are said in the cover page. So there. Okay, now we have to find xy. You need to just make this a tiny bit smaller. Okay, so we want to find this length xy, so we can also use the sine rule. So using the sine rule, we can see that before that we can work out this angle here, because we need it if we're going to use the sine rule. Now the angle Z, to get that angle we just say 180 minus 46 plus y, because we know that all the angles in a triangle add up to 180. So I just worked out y, so I can substitute it in there. So this is 180 minus 46 plus 69.8. So here brackets, very important. Make sure you put them the way I have there. So this is 46 plus 69.8. And as a decimal, this is 64.2. So this angle here is 64.2 degrees. Okay, now I can use the sine rule to work out xy. So the sine rule says xy over the angle opposite xy, sine of it. So sine of 64.2. This is equal to, now use the side that is given in the question in case there was a mistake there. So you don't want to compound the mistake. This is equal to YZ, which is 23 over sine of 46. And then from here you can multiply by sine of 64.2 on both sides. So we have xy. This is equal to 23 over sine 46 times sine of 64.2. Okay, this you again just type in on your calculator. We have a fraction here, 23 over sine of 46 times sine of 64.2. Now here another mistake that I see is some learners will cancel this sign and that sign there. It doesn't work like that, so make sure you don't make that mistake. Write it in on the calculator exactly the way that I have it there. So okay, so this is equal to, I'm just going to write the full calculator display before I round it off. This is 28.786 578.66. And remember, the instructions say you must leave your answer correct to 3 significant figures. So this is 28.8. This is to 3 significant figures. Okay, now the area of the triangle, if you remember that the area of a triangle, this is given by half AB sine of C. So this is for any triangle actually. If you know what these two sides are and the angle between them, all you need to do is half this side times that side multiplied by sine of the angle between them. So as long as you have any two sides and the angle between them, you don't necessarily need to work out the perpendicular height. You can just use this formula. So this is a half. Which two sides am I going to use? I have these two sides and the angle there, so I'm going to use those. So that's xz, half of xz times zy or yz times sine of the angle at z. Okay, so this is a half, 30 times 23, and then sine of 64.2. Okay, so again, this you would just type in on your calculator. And the way we do it, say a half times 30 times 23 times sine of 64.2. And the answer is 310. So I'm just going to write the full calculator display, 310.6099761, and then write the final answer to three significant figures. This will be 311. This is to three significant figures. Right, number 10. We are told that a circle of radius 9 centimeters is inscribed in a square as shown below. We have to find the area of the circle. So the radius is 9, and we know that the formula for the area of a circle, area, is equal to pi times the radius squared. So this is just pi times, what is my radius? 9, so 9 squared. So the information or the instructions on the paper are that you can either use pi on your calculator or 3.14. So I'll just use the one on my calculator. Pi times 9 squared. This is 81 pi. And then as a decimal, so this is 81 pi, or as a decimal, I would write this as 254 point, sorry, I need to write it to three significant figures. Just clean the whole thing. Okay, so this is 254.46900, or maybe let me write the full display as I usually do. This is 254.4690049, and then to three significant figures, this is 254. So this is correct to three significant figures. The area of the square. Now, if I were to measure this length here, this is also the radius of a circle, so that was also 9 centimeters. So my square will be 18 centimeters by 18 centimeters. And we know that the area of a square is just side squared. So the area, this is side squared, so this is 18 squared. This is 324. Okay, now we want to work out the shaded area. Now the shaded area, you can see, is the square minus the circle. That will give this area here, that area there, that area there, and that one all together. But we are only interested in this one and that one. So what we do is we say the area of the square minus the area of the circle, and then divide by 2, because these 4 areas are the same. So we only want these 2, so half of the total area. So our shaded area, this is the area of the square minus the area of the circle, and then we divide by 2 because we're only interested in half of the area. The shaded area is the area outside the circle, but only half of it, because all those 4 sections are equal. Right, so this is, what is the area of the square? This is 324. The area of my circle is 254. And then we divide this by 2. We have 324 minus 254. And then divide this by 2. The answer is 35 centimeters. Centimeters squared, rather. Okay. Then B, we're told that a point A lies A, B, C, D. The point A, B, C, and D lie on the circumference. You can see A, B, C, and D. The lines AB and BC, these are diameters. That means they are chords that pass through the center. Then AC and BD, these are chords on the circle. Line EDF, EDF is a tangent. A tangent just means a line that touches the circle at only one point, and that's D. Then we are given the angle CBD. This angle here is 48 degrees. Now we have to find these angles and give a reason for the angle. Okay, now CAD is 48 degrees. Okay, now the reason that CAD is 48 degrees, this comes down to our circle theorems, and the reason for that is that angles that are subtended, so angles subtended by the same chord, are equal. Okay, so that's one of our circle theorems. So you can see they both come from this chord DC, so they are in fact equal. Okay, then angle ACD. Angle ACD is 90 degrees, and the reason for that is that angles in a semicircle in a semicircle, or that have a chord that is the diameter are right angled. Angles in a semicircle are right angles. Okay, so as long as the chord that you use to subtend the angle is a diameter, then the angle you form at the top there will always be 90 degrees. So the same thing over here, that this angle BDC is also 90 degrees because it has the chord there, which is a diameter. Then ADF, so that's ADF, this angle here, this one is also 90 degrees. Now the reason why it is 90 degrees is that angles between the radius, and a tangent are 90 degrees. Okay, so that is one of our theorems. So this question is just a matter of you recalling these theorems that you learned. Okay, number 11, the point P, Q, R, and S are the vertices of a parallelogram. So I'm going to just quickly label them on the graph. So P is -5, -2, Q is -1, 6, R is 7, 7, and S is 3, -1. Okay, so that's again just for ease of reference on my part. Now we have to find the length of PQ. The formula for finding the length or the distance between any 2 points, need to recall that PQ, this is the square root. You take the x coordinates, subtract them, and then square. So you will say -5 minus -1 squared, and then -2 minus 6, then you square, and this is all under the square root. So you type it in exactly the way I have on my calculator. So we have the square root, open your bracket, -5 minus -1, then you square this, plus, open brackets, -2 minus 6, this is squared, and then equals. So this is the form that we're asked to give in the calculator on the paper, and that is exactly the way the calculator displays it. So this is 4 square root of 5. So this is 4 square root of 5. And that is what we also call the exact value, 4 square root of 5 units. So units represents whether it's centimeters, meters, and so on. Okay, B, we have to find the coordinates of the point M, which is the midpoint of PQ. So we are looking for a midpoint somewhere here. The midpoint, we just use our midpoint formula. So the midpoint, this is the average of the x coordinates, comma, the average of the y coordinates. So our x coordinates, I'll say -5 plus -1 divided by 2. So I have -5 plus -1 divided by 2. And then the y coordinate, I will say -2 plus 6 and then this is divided by 2. So simplify this as far as possible. For the first one, I have -5 plus -1. Divide this by 2. That gives Okay, this is -3. Then you do the same thing for the y coordinate. This is negative, not that one, -2 plus 6, and divide this by 2. This is equal to 2. So our midpoint is -2, 2. Right. Then we have to show that MS is perpendicular to PQ. So this is our midpoint M, and the coordinates are -3, 2. So this is -3, 2. So we would draw a line from M to S, and then we have to show that these two are perpendicular. Now, how do we show that two lines are perpendicular? What you do is you work out the gradient of MS and the gradient of PQ, and then you multiply them. If the answer is -1, then the two lines are in fact perpendicular. Okay, so we need the gradient of MS. So gradient of MS, this is, you know, our formula for M of MS. This is delta y over delta x, or the change in y over the change in x. So M has coordinates -3, 2. S has coordinates, what are the coordinates of S? -3 and -1. Okay, and let me just go ahead and write P as well. P has the coordinates -5, -2. And Q has the coordinates -1 and 6. Okay, so the gradient of MS is the change in y over the change in x. So you can call this one your x1, y1, x2, y2. So say y2 minus y1 over x2 minus x1. So this is -1 minus 2 divided by 3 minus -3. This is a 3. So do this on your calculator. So -1 minus 2 and 3 minus -3. Okay, this is -1/2. And then in the same way we work out the gradient of PQ. So this M of PQ, this is also delta y over delta x. So this is, you can call this your x1, y1, x2, y2, and then y2 is 6 minus -2, and this is divided by -1 minus -5. Then this is what you type in on your calculator. All right, so sorry, I need to do that again. Okay, so we have 6 minus brackets -2 and -1 minus -5, and this is equal to 2. Now we want to test and show that the two are perpendicular. We multiply the gradients, so we say the gradient of ms multiplied by the gradient of pq. This is -1/2 times +2. This is equal to -1. So since the product of the gradients is -1, then the two lines are perpendicular. Okay, so this is mostly just to explain why I was doing all these calculations, and I think the marker would want to understand or check your reasoning why you were working out the gradients, because we know that if two lines are perpendicular, then it means that their gradients are have a product of -1. And now D, we want to work out the area of the parallelogram. Now the area of a parallelogram is given by the length of one side multiplied by the perpendicular height. So I can find the length PQ, which I have here already, and then I multiply it by this one here, and it is perpendicular. So it doesn't matter where I get the perpendicular length. I can say QR and then draw a line perpendicular to QS. But since I know already that MS is perpendicular to PS, I can use those two already. Okay, so the area of my parallelogram area, this is going to be equal to PQ, so that's the length of PQ, and then you multiply this by MS, and the only reason you can do that is because it is perpendicular to MS. Times MS. So PQ we already worked out. That was 4 square root of 5. Let me just scroll up. There's a lot of scrolling up and down, but it's 4 square root of 5. And then MS we work out using the distance formula. I can write down the coordinates of M and the coordinates of S. So M is -3, 2, and S is 3, -1. S is 3 and -1. So the distance formula, you take the x coordinates -3 minus 3 squared, and then 2 minus -1 squared, like that. So this, I would type it in exactly the way I have it on the calculator. And I have 4 square root of 5 times, the times actually does not need to be there, but there's no harm in writing it. times negative 3 minus 3 squared plus open bracket 2 minus negative 1, and then you square this. So my answer is equal to 60 units squared. So this is 60 units squared. Okay, number 12, complete the table for the equation y is equal to x squared. So we are given the x coordinate, the x values, so we just need to complete the table. So you say 2 divided by negative 4 squared. So something you can do on this calculator, you can write 2 over x and click that button, calc, and then you substitute, type in negative 4. This is negative a half, then you write it here. This is negative a half. So again, just go over it again. You make your fraction. This is 2 over, you put the letter x, then you click on this button here, and you want x to be equal to negative 3, and enter. This is negative 2 over 3. Then for the next one, you just press CLC again, and x is negative 2 and equals, the answer is negative 1. Then x is negative 1. So this is a really great calculator. So here, see, when x is negative 1, the answer is sorry, I didn't do this quite right, so I may need to go over these again. Okay, let's just do this. Okay, so very important that when you're doing these things, you type them in correctly. So the x in the denominator must be squared. Okay, then I press calc when x is negative 4, just checking if I did that one correctly. So this should be 1 over 8. This is 1 over 8. And then the second one, I need to change, I think I'll have to change all of these. Okay, then the second one, also just press calc and negative 3, and the answer is 2 over 9. And then the last, second last, we have, I think I should be writing these as decimals, because looking at these ones, okay, so even though that is correct, write them as decimals, because it's easier to plot a decimal than a fraction. Okay, so let's go over this again. Okay, so let's start with the first one. When x is negative 4, we have 1 over 8, which is 0.125. Then the next one is when x is equal to negative 3. 2 over 9, which is 0.222 and so on. So can write 0.2. when x is -2, we have a half, which is 0.5. And then when x is equal to -1, we have 2 here. Now again, you'll notice that these are given to 1 decimal place, so you can also do the same. So this is 0.1, 0.2, 0.5, and so on. Okay, then the next part is on the grid below, draw the graph of y is equal to 2 over x squared. So try and draw that one, scroll down. Okay, so our first point is -4 and 0.1. So look at these points. This is 0, that's 1, so this is 0.5, so that will be 0.1, 0.2, 0.3, 0.4, 0.5. Every 2 squares is 0.1. So we have 0.1, can plot it over here. Then we have -3 and 0.2, so that's 0.1, 0.2. So it's much easier to plot these on a paper than using my computer, but I'll do my best. Then -2 and 0.5, -1 and 2. And the same thing here, there's no value at 0, so it's 1 and 2, 2 and 0.5, 3 and 0.2, then 4 and 0.1. Then you try and draw a nice smooth curve. So I'll do my best to draw one with this pen that I have here. Then it should continue like that. Okay, so it's not that smooth, but that's what it, let me do it. Stop at that value that we're given. Let's try again. Okay, so when you're drawing this on paper, it is definitely going to look much better. Okay, so it's not so smooth because of what I'm using, but something like that. Then the second or the next question is, on the same grid, draw the line y is equal to 1 over 4. The line y is equal to 1 over 4 is a horizontal line. So 1 over 4 is 0.25. Okay, so we can round this off to 0.4. But we can draw 0.25 on this graph. So you look for y is equal to 0.2512. So here, let me just make sure 1, 2. Then this is another one. I don't see any tools here that help me to draw a line, but you draw a line as smooth as possible. You would use a ruler, so I'm going to try and make it as smooth as possible. So like that. So label, always good to label your graphs. So this is y is equal to 2 over x squared, and this is the line y is equal to 1 over 4. Then solving 2 over x squared is equal to 1 over 4. Graphically, you're just going to read these points here where the two lines, the two graphs meet. So try and read them on the graph. This is 2 point. So that looks like 2.9. X is equal to 2.9. That's our first solution here. That's what it looks like. Read it from the graph. And then the second one, this one here, x is equal to negative 2.8. Okay, so when you draw nice smooth symmetrical graphs, you will see that the answers are the same, but I'm just reading off my graph. So I got 2.9 and negative 2.8. Number 13, we have to sketch the graph y is equal to 2x squared minus 5x minus 3, clearly indicating the intercepts on both axes and the coordinates of the turning point. Now, whenever you're given a parabola to sketch, a parabola will either look like that, that means it opens upwards, or it will look like that, that means it opens downwards. Now you may be wondering, how can I tell whether it opens up or down? And that is very easy to do. You just look at this number in front of the x squared. If the number in front of the x squared is positive, then it looks like this. If the number in front of the x squared is negative, then it looks like this. One way I use to remember that is, if I'm positive, then I have a smiley face. If I'm negative, then I have a frowny face. Okay, so positive, smile, that means you're looking up. Negative, frowning, that means you're looking down. Okay, so here our number in front of the x squared is positive, so that means we will have a parabola that has a minimum turning point. So since we say a is equal to 2, so since a is equal to 2 and 2 is positive, it's greater than 0, the parabola has a minimum. Okay, so that means it looks like this. It opens up and it has a minimum point somewhere there. Okay, so what we need to do is find the x and the y intercepts. So the x-intercept, at the x-intercept, y is equal to 0. So you set y is equal to 0. So I have y here. So I'm going to say 0 is equal to 2x squared minus 5x minus 3. So this is a quadratic equation that you solve. You look for two numbers that when you multiply them, the answer is negative 6. So you say the 2 times the negative 3. That's where I get the negative 6 from. And when you add them, the answer is negative 5. So that's negative 6 and positive 1. So I'm just going to change the order that this is written in. So I have 2x squared minus 6x plus x minus 3 is 0. Then the first two terms, you can take 2x out. We have x minus 3. And then the next two terms, x minus 3, 1 is a common factor. So then the 2x and the 1 here, that's invisible. So you have 2x plus 1. And then x minus 3, this is 0. So this means the first bracket is 0, because whenever you're multiplying two terms and the answer is 0, it means the first one is 0, or the second one is 0. Okay, so I have my x-intercepts, -1/2 and -3. And then for the y-intercept, this time x is 0. So in this equation, I'm going to set x is equal to 0. So I have y is equal to 2 times 0 squared minus 5 times 0 minus 3. So here we just get y is equal to -3. Then we need the coordinates of the turning point. The coordinates of the turning point are actually pretty simple to figure out. You can use completing the square, but you don't need to. So those are the coordinates of the turning point. So the coordinates of the turning point, the x-coordinate has -b over 2a. So you take the b value, what is our b in this case? The coefficient of x, so it's negative of -5 divided by 2 times a, which is 2. So this is 5 over 4. This is 1.25. And then from there, to work out the y-coordinate of the turning point, you're going to substitute x is equal to this in the formula for the parabola. So to do that, you'll say y is equal to 2 times x squared, that's 1.25 squared, minus 5 times 1.25 minus 3. So this you type in on your calculator, and we can use the way I showed you now. You have 2, and then you put x squared minus 5 x minus 3, and then you press calc and you put 1.25, and this is equal to -49 over 8, and as a fraction this is -6.125. Okay, so writing it as a coordinate, I have 1.25 comma -6.125. So now we're ready to plot these points on my axis. Okay, so first we have the x-intercepts. The x-intercepts are at -1/2 and 3. So -1/2, you can put it somewhere here, and then 3 will be somewhere there. So it doesn't have to be accurate or exact, but I must see that this is smaller than that one there. And then the y-intercept is -3. So we can put that somewhere here. And then our turning point is at 1.25, so that's maybe somewhere here, and negative, let me just try and make it a little bit more to scale. So okay, so I'll put the -3 here. Okay, and then my minimum is exactly halfway between these 2 points. Okay, and you can see that my parabola will go down like that. So then try and make it as smooth as possible. So again, me drawing this on a computer, it's more difficult to make it smooth than you on pen and paper. So what you should definitely not do is like use a ruler. that one you will not get any marks for that. So this is -3, and then these coordinates are 1.25 and -6.13. This is to 3 significant figures. And then usually like you to write the equation. This is 2x squared minus 5x minus 3. Okay, and label your axes, of course. Okay, so that's how I would want you to solve this one. Number 14, we're told that 2 unbiased dice are thrown. The difference between the scores obtained on each dice is then recorded on the table. Complete the table. So here you just take the bigger number minus the smaller one. So here you have 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. Then this will be 3, 4, 5. 2 minus 1 is 1. This will be 2 minus 2 is 0. 3 minus is 1. And then this is 2, 3, and 4. This is 2. 3 minus 2 is 1. 3 minus 3 is 0. Then 4 minus 3. We're always saying the bigger one minus the smaller one. So already you can see a pattern. I have zeros across here. I have ones here. I have 2s there. This is a 1, 1, 1. This is 2, 2, and 2. And this is 3, 3, and 3. This is a 4, 4, and then this is a 5. Okay, so that's how you do it. You can say 0, 1, 2, 3, 4, 5, 1, and then 0, 1, 2, 3, 4, 2, 1, 0, 1, 2, 3, and so on. So just check that you have completed the table correctly. Then the next one, giving your answers as common fractions in their simplest form, calculate the probability that the difference is equal to 0. So the probability is just how many zeros do you have out of the total number that you have. So we have 6 times 6. There's 6 times 6 possibilities. That's 36. Then you say, how many zeros do I have? I have 1, 2, 3, 4, 5, 6. So I have 6 over 36, which is 1 over 6. So we're told to give our answer as a fraction, and the probability is 1 over 6. Then we have to find the probability that the difference is equal to 1. Same reasoning. You count how many ones do I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 ones out of how many altogether? This is 36. So you can simplify this on your own, or just type it in on your calculator. 10 divided by 36. This is 5 over 18. This is 5 over 18, and the calculator gives you the answer in its simplest form. Then number 4, that the difference is less than 2. So if the difference is less than 2, that means the difference is either 0 or the difference is 1. And the way you'd work this out is you count how many zeros and how many ones do I have all together, and then divide by 36, or you look at the questions you got in the previous the answers you got in the previous question. So the probability that the difference is less than 2 is the same as the probability that the difference is equal to 1 plus the probability that the difference is equal to 0. So this probability that our difference is less than 2, this is the probability that it is equal to 0 plus the probability that it is equal to 1. So this is 1 over 6 plus 5 over 18. . plus 5 over 18. And this is 4 over 9. So that's our answer. So we can try and see, okay, if I just counted how many zeros and ones I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I would say 16 over 36. Sorry, this is 16 over 36, and you can see that the answer is still 4 over 9. Next question. A baker has 6 eggs in the fridge. 2 of them are bad. He picks 3 of the eggs at random. Complete the tree diagram to show the probability of the baker picking 3 eggs at random without replacement. Okay, so this one is a pretty easy tree diagram that should be able to complete. Right. So when we start off, we are told that they are, how many? There's 6 eggs, 2 of them are bad. So what we have is, we have 2 bad. I have 2 that are bad. And we have 4 that are good. Okay, so let's fill in the probabilities in this tree diagram. Okay, so the probability of picking a good egg, there's 4 of them out of 6, so the probability here is 4 out of 6. And these two values together must add up to 1 because there's only 2 options. So this is 2 over 6. So we can always come back later and simplify it. So 4 over 6, that's 2 over 3, and 2 over 6 is 1 over 3. Okay, so at the beginning here we had 6 eggs, and now at this point we have 5 eggs. So it's something good to take note of, that here 1 egg has already been picked. So at this second branch we have 5 eggs left. So we've already picked a good one. That means instead of 4 good eggs, we now have 3. So there is 3 out of 5 chances of picking a good egg the second time round. And you can see that these 2 probabilities here add up to 1 because those are the only 2 options. And then over here, again, you can just take note that there's now 4 eggs left, but remember what I said, that these 2 probabilities must add up to 1. So if this one is half, then at the top here this must be half, because half plus half is equal to 1. Then any other missing spots, we have this one over here. This is 3 over 4. That means this is 1 over 4. And this is 4 over 5. That means this is 1 over 5. Okay, now this part here. So let's go down this branch. We had started with 6 eggs. You picked 1. You have 5 eggs. Then at this point we have 4 eggs left. So you've already picked a bad one, then you pick another bad one. There's no bad eggs left. So the probability of picking another bad egg is 0. It is impossible to pick another bad egg because there is only 2 bad eggs out of the 6. And your first choice, you picked a bad egg. Second choice, you picked another bad egg. So that means there is no more bad eggs. And we say that these 2 probabilities together must add up to 1. So if this one is 0, then that means this one is 1. And that is how you complete the tree diagram. Then Number 2, find the probability that at least 2 of the eggs are bad. Now, when you have questions like this, you need to make sure that you read the word problem correctly and understand when we have words like at least or at most, not more than, not less than. So at least means 2 is the minimum. So 2 is the minimum. So that means you want to look at all these probabilities and look at where he picked 2 or more bad eggs. Okay, so again, all this that I'm writing is not necessarily something you need to write down. It's just explaining the reason behind the working that is to follow. So we want to see what is the probability that he can pick 2 or more bad eggs, but we know there is only 2 bad eggs in the lot, so it is not possible to pick more than 2 bad eggs. So what you do is you go back to your tree diagram and then you try and see what all the branches represent. The first branch here we have good, good, good. So this one is 3 good eggs. So we can write it like this. This is good, good, good. And the next one, this is good, good, bad. So this is good, good, bad. Then we have good, bad, good. So we have good, bad, good. Then we have good, bad, bad. So this is good, bad, and bad. Then we have bad, good, good. Then we have bad, good, bad. Then there is bad, bad, good. And then there's bad, bad, bad. So this is B, B, B. Then to get the probability of each of these scenarios, you just multiply the individual probabilities here. And you can see that this one where we have bad, 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 when I multiply 2 over 6, 1 over 5, and 0, it'll end up at 0 because it is not possible to pick 3 bad eggs when you only have 2. Okay, so back to our question. We have to find the probability that at least 2 of the eggs are bad. Okay, so we want to look at all the scenarios where we have 2 bad eggs. So this first one, 3 good, not what we're looking for. 1 good, not what we're looking for. 1 bad, not what we're looking for. 1 bad, not what we're looking for. 2 bad, yes, this we're going to multiply the probabilities and then we'll add that to another one where we have 2 bad. So the next one here, bad, good, good, not what we're looking for. And this one, bad, good, bad, this has 2 bads, that's what we're looking for. This also has 2 bads. And then this one is also what we're looking for, even though the probability is equal to 0. Then what you do is you are going to all these that I have ticked, you are going to multiply the probabilities along the tree to get to that point, and then you'll add all the individual probabilities together. So for the first one, good, bad, bad, it's 4 over 6. So we have 4 over 6 times 2 over 5 times 1 over 4. That's the first one. And then our next one is this one over here. So you go along the tree and see how you get to this point. You have 2 over 6 times 4 over 5 times 1 over 4. Then the next one is this one here. We have to go like that. So we have 2 over 6 times 1 over 5 times 1. And then the last one is this one over here. You have 2 over 6 times 1 over 5 times 0. Okay, and this you can just work out on the calculator. Okay, so with this fraction here, I'm not going to write 3 individual fractions because I know this is a very long expression. It's not likely to fit on my calculator. So I know with fractions, when I'm multiplying them, I can just multiply the numerators over the denominators multiplying. So I'll say 4 times 2 times 1, that's this sum, and then in the denominator I'll put 6 times 5 times 4, then plus another fraction 2 times 4 times 1, and then 6 times 5 times 4. Then where am I? Okay, then I have 2 over 6, 2 times 1 times 1. Okay, so this 1 here, can write it as 1 over 1. And then in the denominator, I have 6 times 5. And then the last one, which is 0, because anything multiplied by 0 is 0, so you don't even need to write it. Okay, and our answer is 1 over 5. So this is equal to 1 over 5. So our probability here is 1 over 5. Okay, and then remember what I said, that these two fractions, you can always simplify them. This is 2 over 3. And then this one here is 1 over 3, because most of the time you want to leave your answer in its simplest form. Okay, then the next one, we have to find the probability that the baker picks at least one bad egg. So again, we need to remember, what does at least one bad egg mean? So at least one, it means one or more. Okay, so what you can do is you can find the probability that he will pick one bad egg and then add it to this one that we got. Then that will give you the probability of picking at least one, because at least one is the probability of picking just one, including 2 or more. Okay, or another simpler way of thinking about it is the probability of picking at least one is the probability 1 minus the probability of picking 0. Okay, let me say that again. The probability of picking at least one is 1 minus the probability of picking 0 bad eggs. Okay, so probability that it is greater than or equal to 1, that means at least 1. This is 1 minus the probability of picking 0. Okay, so that's easier to do because there's only one way of having 0 bad eggs. Let's see, and that is to pick all of them good. So if you work this out, we have 2 over 3 times 3 over 5 times a half, and then you subtract that from 1. So this is equal to 1 minus 2 over 3 times 3 over 5 and then times a half. So this you can type in on your calculator. We have 1 minus minus 2/3, and this one I can write all of them because it won't take too much space on the calculator, times 3/5 times half, and the answer is 4/5. Right, so again, the probability of picking one or more is just the same as 1 minus the probability of 0, because that's the opposite. There's two opposite scenarios, their probabilities must add up to 1. So 1 or more, the opposite of that is 0. Okay. Right, then our last question, number 15. We are told that the table shows the height h in centimeters of 1,000 Namibia police recruits in a certain year. So this is the data that we are given. Then we have to find the modal height. Now mode, or the modal height, that just means the one with the highest frequency. So you look here, this is 100, 250, and this one here is 600, and the next one is 50. And since 600 is the largest, then our modal height interval is this one here. Okay, so this is the largest, so the modal height interval is the interval from 175 to 185. It has the highest frequency. B, work out the percentage of recruits who are at least, so again, these words, at least 175 centimeters tall. So at least means 175 is the smallest it can be. You want 175 or more. So here, 175 is the lowest, and they increase in that way. So you need to find out how many are at least 175, and then you divide that by the total and then multiply by 100%. So how many are at least 175? It's 600 plus 50. This is 650. So we have 650 recruits that are at least 175 centimeters tall. And now for the percentage, we say 650. We divide this by the total. The total number of recruits, this is 100 plus 250 plus 600 plus 50. So that you can work out on your calculator. So we have 100, 250, 600, 50, that is 1,000. I didn't even need to work it out. It's given to me over here, but anyway, we all have some of those moments. So this is 1,000. Okay, and then you'd multiply this by 100%. Okay, so that you can do on your calculator, but you don't need a calculator because you can see that these two will cancel, those two, and the answer will be 65%. Okay. Right, now on the grid provided, draw a histogram for the height of the recruits. Now one thing you should take note of with this histogram is that the widths are not the same. Like, excuse me, this width here for this class or this interval, for example, goes from 160 to 170. So that means the class width is 10. So I'll write it over here. So this is 10. Then this one goes from 170 to 175. So the class width is 5. This one 175 to 185, so the class width is 10, and this one 185 to 190, it is 5. So very important that you take note that the class intervals are not the same. And when the class intervals are not the same, instead of plotting frequency with against height, we plot the frequency density. Like you can see here, it's a frequency density, not the frequency against the height. So what we need to do is calculate the frequency density. Now the formula for working out the frequency density is pretty easy. So we have frequency density. This is equal to the frequency divided by the class width. Okay, so you just take the frequency that you have divided by the class width, and then that will give you your frequency density. Okay, so I'm gonna copy this table below, and then we'll have row for class width and for frequency density. So this is the table here. Now our class width, we can fill in this row here. We have this one goes from 160 to 170, so the class width is 10, so just say 170 minus 160. Then this one 175 minus 170, class width is 5. 185 minus 175, this is 10. 190 minus 185, this is 5. And now to work out our frequency density, our formula here is just the frequency divided by the class width. So we'll say 100 divided by 10, this is 10. And then we have 250 divided by 5, this is 50. 600 divided by 10, this is 60. And then 50 divided by 5, this is 10. So now we are ready to plot, because we are going to plot the height intervals against our frequency density and not the frequency. Okay, so our graph here is already labeled. Let's just look at what we have. We have 160 to 170. We have 170 to 175. 175 will come over here. And then we have 175 to 185, which will go over here. All right, so now let's go ahead and plot. So from 160 to 170, the height of the bar graph. Remember, a histogram is pretty much like a bar graph, except that there are no spaces between the bars. So let's see. We have a bar here from 160 . Okay, I just want to highlight it so that it's clear for everybody to see. Okay, so that's our first bar graph. So it's from 160 to 170, and the frequency density is 10. The next one is from 170 to 175, and the frequency density is 50. So that's 50. So that is going to be a really tall one. so that's 150 to 175. And then we have our next one that is from 175 to 185, so from here to there, and that one has a height of 60. Very slow. Okay, so it has a height of 60. So that is, let me maybe change the outline just a bit so it is So when you're drawing this, obviously you're not going to make them different colors. I'm just trying to illustrate the difference between this one and the next one. So when it's all black like this, it may be a little bit difficult to distinguish. So not necessarily that in the exam you must draw them differently. I just want to show you where one block begins and the other one ends. Okay, so with these two, quite easy to distinguish, but I was having a problem distinguishing where this one starts and that one ends. Okay, so that's why I made it this color, not for any other reason. That is what you're supposed to do, not at all. Okay, then the last part is from, the last interval rather, is from 185 to 190, and the height, the frequency density is 10. So we're going to draw okay, and I'll make this one black. Okay, just to stick with the theme. So again, this one is just for me to distinguish between these two, but even making it all black is perfectly fine. Okay, it's just here the line doesn't look so nice, quite difficult to distinguish. But in any case, this is how you draw your histogram. There are no spaces between the bars, and you can see that the widths are different because the class intervals are different. All right, then the last question is to estimate the mean height of the recruits. Now with a histogram, we are not given the individual values. We are just told that there is 100 recruits between 160 and 175. So since we are not given individual values, what we do is we take the average of the endpoints and then we'll multiply that by the frequency. And then after that, we will add them all together and divide by the total. So it's the same way you would work out the average. You assume that in this range, all of them had the average of 160 and 175. So you add the two together, divide by 2, you'll get 165. So you assume that you have 100 165s here, and the same thing over there and there and there. and then what you do is you divide by the total. Okay, so let's work it out, and that's why here it says estimate the mean height. So you're not finding the actual mean height, you're estimating. All right, so with our first interval, we are going to say 170 plus 160 divide by 2. Then this value, we are going to multiply it by the frequency of that interval. The frequency is 100. Then in the second class, second interval, we will say 175 plus 170. Then we divide by 2 and we multiply by the frequency. This is 250. And then the next class we have 175 plus 185. Divide this by 2. Then we multiply it by 600, which is the frequency. And then 185 plus 190. Divide by 2, and we multiply this by 50. Then all this, we are going to divide it by the total, which is 1000. Okay, so as it is, you can type it in on your calculator. Okay, so we have a fraction. There. 170 plus 160 divided by 2 times 100. We're running out of space. Okay, so the times 50 doesn't fit there, so I'll write it like this. Okay, let's do this in an easier way. First, I should simplify all of this and then type it in. I think it's too much for my calculator. Very easy to make a mistake. So here I have 170 plus 160 divided by 2. That we can easily work out and then write down. this is 165 times 100. This is 16,500. So I have 16,500. Then the next one, $175 plus 170, divide this by 2, then multiply this by 250. This is 43,125. And 175 plus 185, divide this by 2. $108,000. $185,000, 190. Times 50. That's 9,375. Okay, and this has to be divided by 1,000. So now this we can type on our calculator and it will fit. We have 16,500, 43,125, 108,000, 9,375, all divided by the total, which is 1,000, and that gives us 177. Okay, and this is in meters, I believe, in centimeters rather. Of course, that makes more sense in centimeters. Okay, so that is how you would basically answer the questions in this paper. So the next paper will come out shortly. Keep studying. As you know, the key in mathematics is always to practice. So practice, practice, practice.